Yeah. Okay. All right. I think we're good. All right. So we're talking about integrals. What is an integral? There are multiple good answers to this, but what's an integral? The opposite operation of a derivative. Perfect. Okay. So a derivative takes us down a power, right? An integral brings us up a power. Right? That's what it is. It's the opposite operation of, or the inverse operation of a derivative. Okay? That's important. And what does an integral do for us if we're thinking about a function in its graph? It gives it the area of that function between that function and the x-axis, right? So if I just asked, we're going to do something super simple to start with. If I just said, what's the integral of x squared from 0 to 1, all that's going to do is tell me from 0 to 1 what this area between the x-axis and that curve is. And we should remember using the power rule. I didn't start recording, right? Yeah, okay. Using the power rule, we should be able to reverse this and take an integral of it. So instead of taking a derivative by multiplying by the power and dropping it down by 1, instead we'll increase the power by 1. So this will become x cubed. And then we'll divide by that new power. So x cubed over 3, and we evaluate it from 0 to 1. That's our second part of the fundamental theorem of calculus. As we go back through and do some more of our really review right before the AP test, we're going to talk more about the fundamental theorem of calculus and do a bunch of problems with it. But for now, if you have the limits, you just evaluate it in each of the limits and find the difference. So that's 1 cubed over 3 minus 0 cubed over 3, or 1. Everybody good with that? That's just your basic integral. They don't get much easier than that. True? All right, we're all good? Everyone's good? Everyone at home, you're good? Yeah.
Yes.
Wonderful. Okay. Now, when we say that an integral tells us the area between the curve and the x-axis, that's not always 100% correct, right? That only works if the function is above the x-axis. So if I was talking about the integral from 0 to 1, negative x squared, right? That's not actually going to tell me the area between the x-axis and negative x squared. It's going to give me, because this function is below the x-axis, it's going to give me the opposite of this area. So the area, since this is below the x-axis, my x's always look like alphas. Below the x-axis is below the x-axis. We take the area should be the opposite of this integral. And so we would take the integral, which is negative x cubed over 3, and evaluate it from 0 to 1. We would take the opposite of negative 1/3 minus 0, which is positive. Everybody good with that or no? At home, you good?
Yes.
People here in the classroom, you're good? So important point to remember that the integral gives you the area between the x-axis and the curve, but if that function is below the x-axis, you have to take the opposite of it. We may also have some situations that arise where, let's look at the integral from 0 to 2 of negative x squared plus 1. So we should know what negative x squared plus 1 is, right? It's just a parabola that's flipped upside down, and then we've shifted it up 1 unit. Yeah. So it should look something like this. And we'll note that part of the interval from 0 to 1, our function is above the x-axis, but from 1 to 2, my function is below the x-axis. So if I were to find this integral, the integral itself will give me this as a positive and this as a negative, and part of those will cancel out, and we'll get something that is not the area that we're looking for. Does that make sense to everybody? So what we have to do is we have to split it at x equals 1, where it crosses through the x-axis. You guys at home all good with that?
Yep.
Yes.
Great. So the integral from 0 to 1, negative x squared plus 1 dx. And then instead of adding, we'll subtract, right? Because that's going to give us the opposite. We want the opposite of the one that's below, because the one that's below is negative. So we take the opposite of it. That should give us the full area. And why not? Let's evaluate it. Might as well. What's negative x squared's integral? It should be negative x cubed over 3 still, plus x from 0 to 1, and then we'll subtract the same thing, negative x cubed over 3 plus x from 1 to 2. Good? Okay. Good at home? Negative 1/3 plus 1 minus 0. And then this other one becomes, what is that one? Negative 8/3 plus 2. And then minus negative 1/3 plus 1. And you just do some arithmetic and get an answer. What's that arithmetic come out to be? What is that? Did it come out to be 0? No, it didn't come out to be 0. I did my arithmetic wrong. What did it come out to be? This is 2/3, right? Minus, what is this? Negative 8/3 plus 1/3 is negative 7/3. And then plus the 2 and a minus the 1, so plus 1, negative 7/3, that's negative 4/3. Yeah, 2/3 minus negative 4/3. Come out to be 6/3. That come out right? Is that what you guys get? Or no?
Yes.
Yeah? Are you guys sure? People in the classroom are looking at me like I did my arithmetic wrong, so. They're looking at me like either I did my arithmetic wrong or they did their arithmetic wrong, one of the two. Did you guys actually get 2? I could have done my arithmetic wrong.
Yeah, I got 6/3 or 2.
Okay, all right, we got another 2. Okay. Anybody in here get 2? No? Did I do my, all right, if you guys say so. All right. That's right now? I'm right? Okay. They're telling me I'm right, that my arithmetic's right. So I'm gonna go with my arithmetic's right. Are you sure you're making this thing like too much math? That's the third problem. I thought you said there's too much math. Negative 1/3 plus 1 is 2/3. That's definitely true. Negative 8/3 plus 2 is negative 2/3. Negative 2/3 plus 1/3 should be negative 1/3. And minus 1 should be negative 4/3. Okay, I feel good about my arithmetic. All right. Okay. Y'all gotta get better at arithmetic. Otherwise, I feel like I'm wrong when y'all tell me I'm right. But nobody else got the same answer. Everybody conceptually good with that, though? Okay. All right.
Yes.
Perfect. Okay. next thing we want to talk about is area. So the important things about area. One is if it's above the x-axis, great, you're easy, it's positive. If it's below the x-axis, make it negative. If it crosses through, split into two integrals. If it crosses through multiple times, split into as many integrals as you need to. True? Everyone's good with that here? Bill, good with that at home?
Yep.
Yes.
What if I ask you to find the area between two curves? Let's say the area between, let's go with x squared and y equals 2x. So we're looking for this area right here. The area between y equals x squared and y equals 2x. How do we find that area?
You need to find the range where that area exists. So you,
Okay, so
that
first
thingy
thing,
on the right.
find the point of intersection of these things, right? So set x squared equal to 2x, which is an easy quadratic for us to solve, right? Subtract the 2x, you got x times x minus. So these two functions should intersect each other at x equals 0 and x equals 2. So that's a good start. Whoever that was at home that said that, what do we do next?
You take the integrals from 0 to 2 of y equals 2x and then subtract the integral of the other one.
Yeah. All right. So we take the upper function. Our upper function is 2x. We subtract our lower function, that's x squared. So we have the integral from 0 to 2, so 2x minus x squared dx. You can write it as two separate integrals if you want, but you don't have to. So I know you said to do it as two separate ones, but I always prefer to just do it as one. So I'm going to just leave it as one. And then we integrate. What's the integral of 2x? X squared.
X squared.
Integral of negative x squared ought to be negative x cubed over 3. We'll evaluate from 0 to 2, which should give us 4 minus 8/3 minus 0 minus 0. And 4 minus 8/3, 4 is 12/3. All right. 12/3 minus 8/3 should be 4/3. Good or no? Y'all good here with that? They will not, unless they give you units attached to it, they will not require you to write units squared. I will not require you to. If you want to, it's not wrong, but you don't have to. Any other questions here, people here?
So, why is it 2x minus x squared?
And it should be 2x minus x squared because 2x, for all the x values between 0 and 2, 2x is above x squared. Always the upper function minus the lower. Any other questions here, people here? People at home, do you have any questions?
Nope.
Great. That's correct. Good point. Let's do that. All right, suppose I say here is the function x squared, and here is the function 2x. And say I said, I want to know the area that is between these things from 0 to 3. So suppose I want area between 2x and x squared on the interval 0 to 3. So in this case, because the two functions intersect each other between 0 and 3, we've got to split into two integrals at that point of intersection. So we know that point of intersection already was x equals 2. So we should have the integral from 0 to 2 of 2x minus x squared dx, which we literally just did, right? So I'm not going to force you guys to go through and do that one again. We'll just use our value. But we need to add to that the integral from 2 to 3. And now from 2 to 3, x squared is above 2x. So it's going to be x squared minus 2x. Good with that, Phil? Then that's the difference there. Is going to be x squared minus 2x because right, exactly. Good? Is that a
Oh, no, I'm just playing my pen.
okay, I can do that too. Okay. What's the integral from 0 to 2 of 2x minus x squared? We just did it. It was 4/3. Is that right? 4/3. So we got 4/3, and then plus this integral, which should be x cubed over 3 minus x squared from 2 to 3. And then we'll just evaluate and get an answer. Probably 4/3 plus 3 cubed is 27. 27 divided by 3 is 9. And then minus 9. Right. And then minus 2 cubed is 8, so 8/3, and then minus 8/3 minus 4 ought to be negative 4/3. So we've got 0 minus negative 4/3, that'd be 0 plus 4/3. We have 4/3 plus 4/3, which is 8/3. That's the worst looking 8 I've ever written in my life. It's like it. I don't know. I don't know what that is. Like some sort of like infinite 8. Some like infinite dimensional 8. Did we talk about infinite dimensions here? Okay. Bummer. Not that. Maybe someday. Maybe someday. Someday we'll talk about it. We'll talk about infinity. It's very exciting. Hey, everybody good with that? Everybody here in class good? Everybody at home good?
Yeah.
Yes.
Yes.
So responsive. Good. All right. Okay, so area between curves, area underneath the curve, all that stuff. We need to talk about some of the other integrals we need to know. You have that integral sheet that's posted in the other documents folder. So like you need to know, Philip's got it again. You got to know all of those integrals of all the trig functions, which are just the reverse of the other one. And basically any integral on that sheet you need to know. Y'all good? Y'all gonna memorize all those integrals again? Yeah. Okay. All right. But what we do need to be able to do that's not on that sheet is we need to be able to integrate a bunch of functions that look like, I don't know, something like this. The square root of, you got a number you like, anybody? 4. The square root of 4x minus, anybody got another number they like? 5. 4x minus 5 dx. Anybody remember how to integrate something like this? Yeah? Exactly. This is the chain rule, but in reverse. So we need to look at this as if it is a composition of two different functions. Right? So the 4x minus 5 is inside some other function. It's inside the square root function. So we are going to let u equal 4x minus 5. We're going to get rid of the 4x minus 5. Goodbye, 4x minus 5. We hate you. Okay. If u is 4x minus 5, that means we're going to turn this into the integral of root u. Y'all agree with that? Okay. But we can't integrate root u dx. We have to integrate root u du. So we need to figure out what is du. Well, du is just the derivative of this u term. What's the derivative of 4x minus 5? 4 dx. It's 4 dx. Well, I don't have a 4 dx in my original integral, do I? No, there's no 4 dx. But I could, my toolbar. Tool. This is the problem I always have. I hit the toolbar. Nothing happens. Toolbar doesn't show up. See, it didn't show up. Cool. This time it showed up. We don't have a 4 dx, right? We have a dx, but we could make a 4 dx. There's a 4. Now I have a 4 dx. Can I do that? I can't do that without putting something on the outside that cancels out that 4. What cancels out a 4? 1/4.
Fourth.
Y'all good with that at home?
Yes.
Yep.
Yes.
Yeah.
What?
Yes.
Yes.
Okay, I thought somebody said something different for a second. All right, so we got a 1/4, we got an integral of 4 dx. So what we're gonna do is we're gonna put this 1/4 out here still. The 4 dx will become a du. And we have 1/4 of the integral of root u du. Which we can integrate. Right, root u is just u to the 1/2. And that can just be done using the power rule, yeah? So what's the integral of u to the 1/2? 2/3 u to the 3/2. Plus our constant. Don't forget your plus a constant. And is that a good answer? No. Not a good answer because we need to first simplify 1/4 of 2/3, which should become what? 2/12, which is 1/6. And then u needs to be turned into x. And x is 4x minus 5. So we'll have 4x minus 5 to the 3/2 plus our constant. Very important that we're able to do our u substitutions, because if you can't u sub on your integrals, you're going to struggle with most of the integrals on the AP test. Probably like, well, maybe not most of them, but probably like half of them. Everybody good there? Any questions on that? People at home, questions? My internet connection is unstable. Are you still there at home?
Yes.
Yes.
Perfect. All right. Let's do another one similar to that, but not exactly the same. Let's do, and you guys are going to work on this one on your own for a minute. While I stand here and bounce the lacrosse ball on this graphic. All right. We're going to do the integral of the cube root of, Phil, be a number you like? 8. Cube root of 8x plus 2 dx. This should be pretty straightforward. It should be very similar to the last one we did. All right. Everybody good there? Okay. Ready? Integrate. I will give you a minute. If you have questions, those of you here or at home, let me know. Zoom recording. Okay. What was your u substitution? 8x plus 2 du was 8 dx. So you needed to put in 8 and a 1/8. At home, are you all good with that?
Yes.
Yes.
Okay. I assume those of you that are here will just like tell me if you're not good with that. There's so few of you here that I hope that you won't be like shy about not knowing what's going on. Just like tell me you have a question. Okay. All right. 1/8. 1/8, right? The integral. Oh, now we've got, let's see, 8 dx is du, and then u to the 1/3, right? So u to the 1/3 goes up to u to the 4/3. We divide by 4/3, make that 3/4. So we have 1/8, 3/4 of u to the 4/3. It's just the power rule. Oh, that was you. I thought that was you. That was you. Power rule. Yeah. So just go up by 1. 1/3 plus 1 is 4/3. Okay. And divide by 4/3. Good. See, that was good. You had a question and you asked. That was good. That was good work. I like that. Okay. What do we get here if we simplify this down? 3/32 of u, which was 8x plus 2, to the 4/3 plus 4. All good? All good at home?
Yep.
Wonderful. Did I remember to resume recording? I did. All right, let's do another one. This one's going to be a little different. We're going to do a definite integral. This is important. Let's do the definite integral from 0 Let's do the square root. We should do square root again, make life easy. Let's do the square root of 4x plus 1 from 0 to 2. We didn't do 4x plus 1 already, did we? Not that it really matters. 4x minus 1. Good. All right. All right, let's see if you all remember how to do this on your own for like a second. Should we do it on our own? Yeah? What is that? I don't know what that means. Yeah? Yeah. All right. Yeah, okay. So take a minute and do this one on your own. Okay, ready, go. Let's do another one on your own. All right. So we're going to integrate 0 to 2 root 4x plus 1. We're going to let u equal 4x plus 1, right? Du will be 4 dx. We'll put it on our 4. We'll put it on our 1/4 like we did before. Everybody's good with that still, I think? There's nothing different yet. Okay. We end up getting then an integral, or 1/4 of an integral of u to the 1/2 du, which looks very similar to what we had before. But since it's a definite integral, we have to have our limits on there. Now, these limits are x values. Our integral is now in terms of u. So we have to convert our x's into u's. And that is probably where, if we were having an issue with our evaluation, that might have come from. So if x is 0, u should be 1. And if x is 2, u should be 9. So we're now looking at an integral from 1 to 9. You all good with that at home?
Yes.
Great. You all good with that here in class? Wonderful. Okay. So now the arithmetic should be much easier. Yeah? So this becomes 1/4 of 2/3 u to the 3/2 from 1 to 9. And the good thing is we do not have to convert this back into terms of x. Since we turned our limits of integration into u, the integral is in u. I can just evaluate it right here. We're looking for a number, right? We're not looking for an algebraic expression. We're looking for a number, so we'll just plug it in. First off, 1/4 and 2/3 becomes like we had before, 1/6. And then I'm going to write this out. We're just going to write 9 to the 3/2 minus 1 to the 3/2, and then we'll evaluate that for a second. Some people in first grade were having a little bit of difficulty evaluating 9 to the 3/2, or like something to the 3/2. So how do you evaluate something to the 3/2 power? What do you do first?
Cube it.
You could cube it first. Normally, I would not cube it first because then you're going to end up with 9 cubed, which is 729, which isn't so bad. But you may not know the square root of 729 off the top of your head. Probably don't. You might. But you can do the bottom, the over 2 part first. You can square root it first. So first we'll square root the 9, which gives us 3. And then we will cube the 3, which will give us 27, which makes life a lot easier. So my recommendation is whenever you're doing something like raising to the 3/2 or the 2/3 or the 5/2 or whatever, do the root first and then do the upper part of the fraction of that exponent first for a second. Good? People here good? People at home good? People at home good?
Yes.
Yeah.
When you don't answer, I yell. So what did we say, 27? And then 1 to the 3/2 edges. So we got 26 over 6, which should be 13 over. All good? Any questions with that? Now, if you had gone through and converted this back into terms of x, then you would convert this 1 and this 9 back to your 0 and 2, and you'd get the same answer. But personally, I say just once convert it into terms of u and then finish it off in terms of u if it's a definite integral. All good? 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 Everyone's good? I pointed at everybody in the class here and made sure they were good. Good?
Yes.
Yes.
Good.
I'm not going to do it 21 more times for everybody in the video. All right, let's do another one. You guys want to do another one like that with a definite integral, or we want to do a more difficult u substitution that's an indefinite integral? a second. Okay, a more difficult indefinite integral, indefinite integral use stuff. All right, let's do this. Let's do, this will be a fun one. Let's do the integral of, x cubed times the square root of 2x. No, let's just do x squared. Let's do x squared. What do you think? Plus or minus? Anybody have a preference? Okay, there are 8 of you in the classroom. Who wants plus? It looks like it's plus. Just one for minus? Plus. Somebody at home, give me a number.
7.
1.
1. Done. Okay. All right. All right. See if you can do this one. I'm gonna give you guys a minute or so to work through it. Ready, go. Resume recording. Okay. All right. We got x cubed root x squared plus 1. So what's the u sub we're probably trying to use here? Okay. X squared plus 1. It's the thing inside of the thing that's kind of annoying, right? Okay. So what is du then? 2x dx. Okay, well, I don't have 2x dx. I have x cubed dx. Okay. I can get a 2 in there, right? That's easy enough. There's the 2, and there's the 1/2. That's okay, right? Everybody at home good with that?
Yes.
Yes.
People hear everything? Okay. 2x cubed dx is still not 2x dx though, but I could just get rid of the 2x cubed to make it 2x and an x squared separate from it. That's what we're going to do. So I'm going to rewrite this as 1/2 of the integral of x squared root x squared plus 1 times 2x dx. Everybody good with that? That should be equivalent. So in that case, I can replace the x squared plus 1 with u, and I can replace the 2x dx with du. But what about that last x squared? It'll still be left. X
Become
squared
u minus 1.
u minus 1. Exactly. We're going to use that original substitution that we had, and we're going to change it into u minus, solve for the x squared. So this now gives us 1/2 of the integral of u minus 1 root u, or u to the 1/2, du. All good? Okay. And then we will distribute the u to the 1/2 to the u minus 1, giving us 1/2 of u to the 3/2 minus u to the 3/2 minus u to the 1/2 du. And then we integrate. All good? Everybody good with that? So u to the 3/2 becomes 1/2, and which goes 2/5 u to the 5/2 minus a 2/3 u to the 3/2 plus our constant. And we're going to distribute the 1/2 through everything to make that a 1/5 and a 1/3. And our final answer should be 1/5 u, which was x squared plus 1, 5/2 minus 1/3 x squared plus 1 to 3/2 plus our constant. Any questions on that? Everybody okay with that? We're all good? Okay. Cool. All right. Is there anything that anybody wants to talk about with integrals that you think we should further review? Anybody in class got anything here in the in-person people? Anybody at home got anything else with integrals that you want to go back over and review?
Wait, I have a question. There was
Yeah.
this thing we did for like finding the areas on graphs, except it was like we used y in it as well. I don't really remember what it was though.
Okay, yeah, we might have integrated in terms of y. Yes, we could do one of those. That's a good thing to talk about. So let's do let me think about a good problem here to do. let's do this. Let's integrate. Let's find the area. What do I want to do? Let's find the area. There's natural log of x. So let's do this. Yeah, let's find the area between, let's see, 1 and 2 of natural log of x. And so we're going to find this area right here. Is that what you mean? Well, that's not what you don't know if that's what you mean yet, but we're going to pretend that's what you mean. That's what you mean. Okay. We're recording? Oh, good. How are we going to find that area? How would we normally find that area? Normally, what would we do? If this was like, if somebody hadn't asked me about doing things in terms of y, and I just said find this area, what would you think that you would do? Right. You just do the integral of L and x, right? From 1 to 2. Easy enough. Anybody know what the integral of L and x is? Guess that's not what I told you guys to memorize. Guess that requires integration by parts. Guess that's something you learn in the second semester of calculus. You don't know that it's x ln x minus x. Oh well. So we can't do that. This is calc 2. Calc 2. That's it. Calc 2. We don't know how to do calc 2 yet. So we got to find some other way to do this. So we can also integrate in terms of y. So we have to look at the rightmost function and the leftmost function. And we're going to integrate using y value. So what's the lowest y value in this region? 0. Exactly. Maybe I should have said 1 to e. That would have been a better choice. That's fine. This will be fine. Okay. What's the highest y value in this region? Right here, right? That's the highest y value in that region. Everybody agree with that? Well, what is that? It's y equals, this is the natural log of 2, right? I'm at 2. Y is the natural log of 2. So we're going to integrate this from 0 to the natural log of 2. And we do the rightmost function minus the leftmost function. Well, what bounds the right portion of this region? X equals 2. So 2. What's the left function? What region or what function bounds the left part of this region? This does, right? Oh, you can do that. That's before the century. This does, right? The natural log function, right? On the left, for any y value that I choose, suppose I choose this y value, right? The right function is x equals 2. The left function is natural log of x. Right? But we have to write that function in terms of y. So if y equals natural log of x, what does x equal? How do you solve that for x?
Is it e to the y?
Yeah, you just exponentiate it, right? We do e to the y equals e to the natural log of x. So e to the natural log of x is x, and e to the y is e to the y. So the left part of this is bounded by x equals e to the y. So we do the right function minus the left function, dy, integrated from the bottom to the top. Y'all remember that or no? Looking at the faces in person, we have less recollection of that than anything else we've done. At home, are we also having less recollection of that?
Yeah.
Yes.
Yeah. Okay. We'll do another one of these after this one, and then when we get into volume, we're actually going to do a bunch of stuff in terms of y, so you're going to get more used to doing them in terms of y. But we'll do another one after this. Conceptually, does that make sense? It's bottom to top, 0 to ln 2, of right minus left. Instead of when we do it in terms of x, we do left to right, of top minus bottom. We didn't, our bottom is 0, so we're not subtracting anything. Good? Okay, so what do we get when we integrate 2 in terms of y? 2 y, right? Integral of 2 is 2 2 times the variable. Variable is y. What's the integral of e to the y? E to the y. So 2y minus e to the y from 0 to ln 2. Just plug in ln 2 and plug in 0. 2 ln 2 minus e to the ln 2 minus, plug in 0, you got 0 minus e to the 0. And what does that come out to be? 2 ln 2. What's e to the ln of 2?
2.
2, exactly. So we have 2 ln 2 minus 2. And then minus a negative e to the 0. E to the 0 is 1. Minus
1.
e to the 1 is plus 1. So this ends up being 2 ln 2 minus 1. Good or no? Is that what you were wanting to do? Was doing it in terms of y like that?
Yeah, but it's still a little bit confusing.
Let's do another one. Okay, good. Okay, I don't know if you guys can hear that at home. The question was, how come we use e to the y as the left portion of it rather than just 1, because we're going to 1? Because this distance is always 2 units minus however far over we've gone in terms of x here. So I'm gonna write this is an x value, right? X equals 2. And then the distance from here to here is 2 minus whatever this x value is. Right? This is just some x. So this is 2 minus x. And so x here is related to y equals ln this x, which can be written as x equals. Does that make sense? Yeah. And that's going to be a really important thing when we start talking about volume also, is sometimes we're going to have to, like, you're not going to understand exactly what I'm saying right now, but like sometimes this is going to be like the radius of something, and you're going to have to find the value of that radius. It's going to be this whole thing minus that little piece. It'll make more sense in a bit. Does that make sense to everybody at home too? Hello?
Yes.
Yes. All right. So let's do another one of these in terms of y. Cool. Okay, we'll do. I will do it as soon as this class is over. Perfect. Sounds great. All right. Yep. Thanks. I appreciate you bringing it by. All right. Let's do another one. How about let's do this. Let's find the area of here is y equals x cubed. And I want to find this region right here. We'll call this 8 up here. So y equals x cubed. We want to find the area of that region from 0 up to 8. So this time we're looking at it going towards the y-axis rather than towards the x-axis and doing it in terms of. Good? So how would we go about this one? We're going to go bottom, top. So what's the bottom part of the region? 0. The top part of the region is 8. And since we're doing it in terms of y, we're going to have to rewrite y equals x cubed in the terms of y. So x will equal the cubed root of y, or y to the 1/3, whichever way you want to put it as. Either one's good. And so we're going to integrate from 0 to 8, y to the 1/3 dy. There's only just the one function here this time. There's no other function because we're going towards the y-axis. You all good with that here in person? Are y'all good with that at home?
Yes.
Wonderful. And we integrate y to the 1/3 and we get 3/4 y to the 4/3. And we just go from 0 to 8. And this is why I always do the root part of these first rather than the exponent, the numerator of that power first. It's 8 to the 4th, 4 to the 8 to the 4th. And, probably 1,000, but I think. Is that right? No, that's not right. That's nowhere close to right. I don't know. That's why I don't do it first. So this becomes 3/4 of the cube root of 8 is 2, and 2 to the 4th is 16. Okay. And then minus 0. So we've just got 3/4 of 16, which should be right. Good or no? Good. Exactly. Yep. Question was this one we just had, even though this one had one function, just like the last one had one function, this time, since we're going towards 0 was the bound on this, the minus is the minus 0. Whereas, if I had asked you, I could have asked you, like, what's this area right here? I guess we can look at 2 then, right? So from 2 here, we would do 2 minus y to the 1/3. And that would give us this region. Whereas we wouldn't want to do that because we could do it just in terms of x easily enough with x cubed. But does that make sense? People at home, how do you feel about that?
Good.
Good. Everyone good?
I have a question.
Oh, okay. What's your question?
How would this look if it was in like the second, third, or fourth quadrant?
In terms of what do you mean? Like how would it look? Like with the same function or?
No, just like area using, finding the area using y in a different quadrant.
So just like with when we're doing in terms of x, right? Anything above the x-axis is positive, anything below the x-axis is negative. But when we do it in terms of y, anything to the right of the y-axis will come out positive, and anything to the left of the y-axis comes out to be negative. So then you have to flip it if it's to the left of the y.
So if it's on the left, then you make the integral negative.
Correct, if you're talking specifically about area.
Right.
But in this case, I guess I said area, but it's right area. So if I just said what's the integral, then cool. But if I said the area, you got to make it negative to the left. That is correct.
Okay, thank you.
Good question. Anybody else questions at home? Anybody else here questions? All right, I think that's a good place for us to stop today. I think that's good. We will pick up tomorrow starting with volume, and we're going to try and slowly move our way through volume. I mean, not too slow because we got to get through it, but like I want to make sure we're understanding it, especially after only 2 days of review after 3 months off. So cool.